Okay. Welcome, Diego. We are talking about reading geotechnical reports and, of course, the foundation decisions that follow. So, like you're kind of starting to realize probably at this point about the PrepARE program, we're going to be focusing on sort of both practice and the ARE application. Um, so basically, reading the geotechnical reports is kind of the preliminary process we have to go through to kind of build what can be an exceptional basis of design decision making, both in pre-design and in the early stages of design. So you kind of have to think about it in terms of two stages of what impacts the geotechnical report might have. If you get a geotechnical report upfront with your initial information package, or during the process of creating a proposal or in a design competition, um, then you may actually have impacts in that geotechnical report that affect the location of the building or that modify the entirety of the building design. Um, However, there may also just be after you get a geotechnical report potentially later on, or just due to, the simplicity of the soil or the nature of the geotechnical condition. It may only impact the decisions around the foundation alone, and it may not impact the building at all. So that's kind of important to note. I'm going to leave my mouse over here. All right. So essentially, Diego, I know you have a little bit more information than kind of the broad swath of ARE candidates. So some of this is geared toward people who are brand new to what a geotechnical report is. So we're doing a combination of knowledge gaining and gathering, and then also learning how to analyze it. But essentially, geotechnical reports, they will take soil samples, either using a a hand auger, or a sort of mechanized um, process to get some soil samples, send them to the lab, and actually test the chemical composition and structural integrity of the soil itself. Why this matters. Essentially, the ARE and practice are fairly aligned when it comes to geotechnical reports and how they should sort of be used, which is nice. It's one of the better evolutions from ARE 4.0 to ARE 5.0, I think, than some other arenas. And it's one of the more scientifically technical pieces that exists um, uh, in essentially the programming and analysis exam. So the most important part of what a geotechnical report is for an architect and the primary functional piece is that it helps us, it essentially defines our foundation type selection. But it doesn't just say you have to use this. Essentially, what they're analyzing for is almost a binary analysis of different factors that point to it is good in this condition or bad in this condition. The geotech engineer will kind of take that amalgamation of data and provide recommendations, but that recommendation list usually is kind of a broad swath of options that you could pick. And then it's up to you to determine based off of the soil analysis and composition which way you want to go with it and which one's going to be most economical. So speaking of economics, it does and can have a profound impact on building cost. Depending on the goals of your project. The soil strategy, the foundation strategy can be exceptional. It does have potentially an impact on your site layout and risk. If you want to put a building in a location on site where there's a high measure of clay versus a location on site that has a high measure of sand in the soil, could have profound impacts on the risk of your building in terms of liquefaction or differential settlement. So those are things to consider and we'll be considering going forward. And then what about the ARE specifically? These kinds of concepts are tested on the ARE, but they're usually kind of indirectly tested with regard to the geotechnical report itself. And usually they're questioning something specific about a project or a proposal or the program development of what that project could be. And then the geotechnical report is kind of a backdrop or indirect reference in many cases. One thing that kind of is important to note, liability is less important on programming and analysis. But it's much more important in this context in our conversation to think about it in terms of practice. But this does feed back into Diego. I know you're studying for practice management and project management right now, and it's actually important to know that how we set up certain contract types. Typically speaking, the geotechnical engineer becomes liable for their investigation. It is essentially engineering. It's an engineering analysis of the soil that we are entitled to rely upon in a legal setting. So that means that we can make decisions within the geotechnical report. And if for some reason the geotechnical report is wrong and our building fails, then the liability then passes to the geotechnical engineer. That's important. Um, so that actually exists in the B101 contract. So the owner in this case would essentially provide it with the initial information package. Or if it's acquired outside of the initial information package itself, it is still considered a piece of the initial information package when acquired. So let's get into some of the sort of operational considerations. Essentially, the architect is going to effectively try to target just specific sections. They're going to look at the structural recommendations. This will have actions and solutions that the geotechnical engineer feels are appropriate for that site. And again, it's not going to be just one. There may be specific foundation design criteria, especially if you have a highly complex site and soil composition. If you have a very large site that's being analyzed, it may be quite a lengthy soils report, and the foundation design criteria might be different in different areas of the site. Um, there will be preparation notes. These are going to be a little bit more for the contractor and a little less for design, but something to consider and sometimes are important to the design that we choose. But steps that need to happen with the soil prior to construction. In some cases, whoops, sorry. In some cases, that could mean, let me get back to that. In some cases, that could mean extra compaction or needing to excavate loose soil and replacing it. That sort of thing. Um, Risks and special conditions, it's kind of hard to nail down exactly what this is, but there are definitely going to be some conditions that are discovered where there are challenges or unique requirements. You could have essentially a good example would be like air pockets in the soil or something like that that are identified but can't be measured across the site, something like that. So all of these things together really give us kind of a whole picture of the condition of the land that we're putting the building on to make informed decisions about our not only our building design and foundation design, but also the location and potential volume of the building. Diego, just flag me if the truck outside is just type a message up for me if the sound is too much and I'll pause and wait for it, but I think it's probably okay. Um, the geotechnical report can, like I said, be quite lengthy. There are many sections. Not all of them relate to us. And so, for people who are brand new to geotechnical reporting, these are some of the things that are most important, particularly the engineering recommendations. That is almost unilaterally advised as the starting point for anyone reading a geotechnical report because it's kind of the most important context within which we're going to be considering all the other analysis and conclusions that the geotechnical engineer has come to. It's important to note that the goal for us in almost all cases is to protect building stability while reducing cost. So we're looking for the simplest foundation solution that costs the least, that responds to the conditions of the site in a way that will protect the integrity of the structure over time. So first, Site preparation and the engineering recommendations is really important to just take a look at that and see what are we considering. Are we limited to deep foundations or can we use shallow foundations? If we can use shallow foundations, which kind? And then we start to analyze, kind of run it up, I guess, take it down the flagpole and start looking at each of those avenues individually. The next most important piece is kind of settlement and movement. We need to understand if we're going to choose a shallow foundation or a deep foundation, or if we have two different options of a shallow foundation, how's it going to behave with the soil that is there? And what risks are present if we choose certain options. We're then going to look at groundwater conditions. And particularly speaking, groundwater is probably the second most important, but doesn't necessarily have to be the second thing chronologically that we consider. Because if there is water in the general area, whether it's elevation or kind of like if it's a water table thing or if you have like a stream with silt, on the side of it or something like that, that is going to be one of the most impactful things that happens in the early stages of design because water is one of the most powerful pressures that can be put on our building, even on the ground. Um, So then we also have essentially those special conditions. This example report doesn't have a profound amount of special conditions, but there are things in it that we could take a look at if you'd like to. But essentially things like liquefaction, certain slope instability, corrosive soils is a really fascinating one in terms of now we have to think about like I forget the term for it, but essentially, is it ionize or anyway? Uh, but corrosive soils can have a profound impact on plumbing and our foundations. So these conditions of special conditions certainly would override any standard solutions that we would have in an otherwise kind of standard soil application. So let's take a look at the READ strategy. This is a fairly linear approach to how we would approach the geotechnical report. First and foremost, we're going to start with those recommendations, take a look at and contextualize what our options are. We're then going to identify the foundation type that we would want to use, right? So which foundation type are we going to choose, right? And that's kind of the critical piece of that one. Um, we'll check for appropriateness of that foundation type on the site preparation requirements. We'll scan the report for any movement or water impacts on our chosen foundation type. And then we'll flag any special conditions that may impact that decision or potentially invalidate our decision. And then we'll extract any decisions we need to make that are going to impact the design process going forward. So most importantly here, we're looking at extracting A, the foundation type, and B, any acceptable impacts that will affect the design down the road. So this one actually, I wasn't supposed to have it be a clickable one, but here we go. Click through them again. And effectively, that foundation type step is kind of the most important part of the process, and everything else after that is a check, is basically analyzing any of the other pressures on the project. So you've got kind of two chapters. There's like select the foundation and then analyze what we need to design around with that selected foundation type. What you're looking at here is kind of this is effectively the index and or the legend. But your report's going to start with like a narrative summary. It's kind of the geotechnical engineer summarizing all of the information, and then of course giving you a legend so that you can read how their report is going to essentially function. So the narrative summary and legend and any contextual information will be in the first sections. And so it's important to be able to reference back to that, and you'll see in a couple slides why that's important. Um, there usually is a mapping of some sort to say this is where the analysis on this site happened. because each bore is going to have a complete analysis and they could have profound impacts on what your decisions are if you're to build in certain locations of that site. So, for instance, the soil over here, where perhaps it looks like maybe there was a parking lot at some point, probably has a different soil composition than over here, where it's heavily wooded and is kind of still going through the natural cycle of soil displacement and replacement. And so this is why the legend is super important, because the data in the geotechnical report is impossible to read without that legend. Um, Not every soils report looks the same. And so, at least in practice, you should expect to see and spend some time getting oriented to each geotechnical engineer and labs graphic standards and the way that they communicate this analysis. But on the ARE, it's also important to sort of reinforce your experience to be able to see to have more experience with different variable reports so that you're not caught off guard by a representation technique because this is not an industry standard per se. They may look very similar, but each one may have a different way of displaying the information. So my best advice on the ARE is try to expose yourself to as much possible or as many possible reports as you can without going overboard. So at least do like 3 to 5 different geotechnical reports in your studies to reference. Um, we lost our sand image. So let's talk a little bit about soil properties and characteristics. The four basic soil properties that we're considering. Let me see if I click if it'll come in. We lost our sand image. Um, There are four basic soil types, and they predominantly there are different gradations, but these are kind of if you boil it down to your simple, most easily understood impacts of predominant soil presence: clay, sand, silt, and rock. Clay, being super super fine sheared particulates have a way of absorbing water, where something like sand the water would just flow through. So it absorbs water and therefore is highly subject to expansion and shrinkage, which you can see oftentimes in like desert landscapes. The foothills will often have like clay wherever they have like an elevated valley. But essentially, it tends to bond, and then as it shrinks and dries out, it'll just kind of break and crack, and it creates a lot of movement. With sand, it has super high drainage but very low cohesion, so it doesn't absorb water, and so it's fairly stable. But at the same time, it's very sensitive to settlement. The best example I have from when I was a kid to like think about this is I went to like a fair or carnival once, and I got one of those like glass bottles where you put the different colored sand in it. And I never touched it, I think. It just sat on my shelf for like 10 years. And after 10 years, all the colored sand had just settled and mixed. And it was like 15% less full. And it was just all like a muddy mix of all the colors of sand. So that happens over time, inevitably. Silt is somewhere in between the settlement risk of sand, but the problem with silt is that it just has a lot of movement, and so it is unstable. It does drain a little bit, but it definitely loses its strength when disturbed, and it's very hard to compact silt. And then, of course, the most natural and stable way of, I guess, uh, what's the term I'm thinking of just placing your building, I guess. The most stable way of placing your building would be on rock, on bedrock, because it just does not move. And so that's pretty stable. Now, rock also has a consideration of how dense the rock breakdown is. If you're on bedrock, it's pretty much just solid rock base. But they also have different gradations of how rocky the soil is, with a mix of potentially clay or sand. So, the different densities of rock content in an otherwise more particulate ground makeup is also a consideration. All right, so we know a little bit about reading geotechnical reports, and we'll get into some of that too with some sample questions that are coming up. But I also want to talk about foundation decisions. And this is where I think it's really important to contextualize what we're doing with the ARE. So first up, let's just look at like what are the considerations of foundation strategy and how do we choose and map them? Essentially, what we're looking for is what you would consider a good soil. Good soil is going to present your best opportunity for a very simple solution of spread footings. And that's going to be your most economical option, spread footings, or just slab on grade, depending on the needs of the project and the building. Your moderate soils are going to push you to a slightly more expensive or complex foundation. It may still be shallow, but a mat foundation. It's a whole lot of concrete, a whole lot of rebar. It just responds to some of the instability or flexibility of soils that are not exactly ideal. Then we have poor soils. If we have poor soils, essentially the goal is just bypass. You really have two goals. You can either bypass the bad soil to get to the good soil underneath, or you can use piles or caissons in a way where you're trying to create enough surface contact with the bad soil so that the friction gives it stability. And so that friction concept is really important for combating poor soils. And then lastly, we have expansive soils. This is where you're going to have like a stiffened slab or a deeper system. Expansive soils are one of the things that it's more of a understanding the behavior and tectonics of the soil than the nature of the soil itself in selecting which foundation type. So we have to ask ourselves at this point, what is a good or bad soil? Good or poor or moderate, and what defines that? And this is a critical question to ask not only for yourself in practice, but really when you're approaching the ARE, um, specifically for the ARE 5.0, it's important to understand the structure of the ARE, and we're going to talk about that here. So essentially, um, there we go. So the area is built on a taxonomy of essentially education that begins with you need to remember some information to be able to understand a situation, to apply your knowledge to that understanding, and then also to be able to analyze a situation and evaluate your options to ultimately create something. So the ARE functions here. And if you don't know this information that I'm about to show you, you're not going to be able to get to the higher tiers of this taxonomy that the area is built on and is going to be testing you on. So the fact of the matter is, they're not just going to ask what is the best what is the best foundation type for sandy soil, right? They're going to present a report. You'll have to read the report. So that's the analyzing piece, and you'll have to evaluate what your pathways forward are, potentially even against other options. So that said, we're going to jump into a few of the foundation tables to kind of the foundation selection tables that I've created for one of our videos to understand that a little better. But I did want to take a moment. I noticed we had somebody else jump in. Welcome, Lily. And so I wanted to give you some background that in our PrepARE courses, this study hall, we try to be as conversational as possible. I know I'm talking a lot, but feel free to just pop open your mic and ask me a question at any point. Ask me for clarification or to repeat anything. And also, if you you know want to just type something up, you're welcome to as well. I try to watch the meeting chat as I'm presenting. Um, so let's I guess let's get going. So let me kind of jump back into the content here and reorient us. So now we're thinking about the cognitive structure of the ARE, right? You're not going to be able to answer questions about this unless you have the base information. The base information takes time. Sorry. It takes time and patience and really visualizing what the applications are. So some of this can be rote memory that you need to figure out in order to proceed into the analysis piece, but then some of it is kind of just common sense and understanding the physics of the thing. Um, so this table is probably our biggest table, and I'm not going to. There are a handful of these, so I'm not going to go into the details of every single line of these tables because they're essentially taken out of. This one probably was the structures book mixed with um, not Architect Studio Companion, a little bit of building construction. I can figure it out. If you guys are curious which primary resources I used for this, I will pull them for you. Just send me an email. Lily, for your edification, every single one of my courses is produced using the ARE 5.0 NCARB matrix for the resources that were used to create the exam. Um, so here we have we're looking at site and soil conditions and foundation selection, right? So we're looking at on the left-hand side our site condition, and then on in the middle column, what is our primary concern? And on the right column, what is the recommended foundation strategy? This is kind of um, broad, high-level table that gives you a sense of kind of your broadest and probably most orienting decision class. And I say decision class because um, you start here, right? You have to understand what the site condition is to understand what your primary and secondary concerns are. And then you look at other impacts and you make informed decisions down the road. So essentially, looking at a rock foundation, if it's over bedrock, it has obviously the highest bearing capacity. And if you can pour a foundation directly up to it, you can do shallow foundations, direct bearing on rock. That's fairly uncommon though. Dense sand and gravel, you're going to get good drainage, so you don't have to worry too much about like liquefaction or expansion, and it's going to have some settlement. But that's a good option for like spread footings and mat foundations. You don't have to go deep because it's dense. If you're in a site that has, let's go to like clay, right? Um, Clay with high plasticity. Plasticity is essentially its ability to expand and contract, and acting plastic. It has high shrink and swell movement, and so it's an unstable soil. So in that one, you're going to use deep foundations, piers, and piles, and or employing some degree of moisture control. For instance, there's a lot of high plasticity clay in Southern California, and even if I'm using a shallow foundation, I have to do a lot of moisture control. So I'm using French drains around the foundations of my buildings almost everywhere I design. So that's like an alternate here where I didn't, it's too expensive to use a deep pier or pile. So just French drain it so there's not enough fluidity impact around the foundation. Organic soils, not really great. And of course, you have to consider in seismic zones, liquefaction is very much a primary concern. And the you oftentimes are using deep foundations or like a reinforced raft or mat foundation. Um, we'll get a little bit more well, we'll just talk through it. We'll see how much time do we have. We got some time, but I want you guys to have time to ask questions. So I'm going to jump through a few of these. Um, you are going to be presented with questions about shallow versus deep foundations. They're like the two different primary categories of foundations. And so in your head, be thinking about like, well, this is my first decision, shallow or deep. Um, Soil bearing capacity is incredibly important. High capacity of soil bearing, that's essentially your like pounds per square foot, is going to be great for shallow foundations, while deep foundations um, are appropriate for when there's low capacity and you need more capacity. So you need more friction, you need more surface area. Settlement risk. If the settlement is low, shallow foundation. If the settlement risk is high, you're going to want to go deep. For your groundwater table, if your groundwater table is so deep it doesn't affect your building, you can go shallow. If your groundwater table is high, then you're going to want to go deep because you're going to need, again, more friction, buoyancy, stability. Um, and then cost and constructability, of course, shallow foundations are going to be cheaper, deep foundations are going to be very expensive. So it doesn't take much time to remember a table like this, but it does take some familiarity. So spend some time with it and just try to internalize it in the way your mind thinks about these solutions. Um, Bearing capacity and settlement. So your different soil conditions are going to have different settlement and bearing capacity implications. So loose sand, high settlement. It's going to require either preloading or deep piles or extra compaction. Soft clays are going to settle over time, so you can reinforce it to stop the movement with like a geogrid, or you can go with a deep foundation. Oftentimes, the geogrid is implemented with like mat foundations and raft foundations. Expansive clays, you're going to have a lot of volume change, so you can do a series of deep piers, post-tension slabs, moisture barriers. Like I said, with French drains around it, just move the water away from the building so it doesn't affect it as much. And organic soils, you really don't want to operate on organic soils. If they ever pop up, that's going to be one of the things that you're most likely just going to want to try and excavate or avoid entirely and build somewhere else on site. Groundwater management. The things that you're concerned about are high water table, seasonal fluctuation, like if you have high rains and percolation, and artesian water pressure. So the high water table is pretty easy. It's just going to say like how high it is, and if it's close enough to your foundation, you're going to have concerns because of the soil. The soil capacity is going to be reduced. It may move. And then seasonal fluctuation. There are that it really depends on that one. That one's more of a offsite like environmental context consideration. So you really need to think about if there's high rains that are not percolating, you're gonna have to move water away from the building. But if you have high percolation, you might be able to use cisterns or something like that to just move the water to a place where it's not going to affect your foundation. Artesian water pressure is upward forces that can kind of unsettle your building. Um, you'd use drainage systems. Like I said, the French drain is great for that too. Or subsurface drainage systems or anchored deep piles. So that just means it's anchored deep enough that it just can't move with the water pressure. Um, Shrink and swell behavior, that's going to have to do with if it's expansive clay or if there's moisture. There's really only two considerations for that. So the expansive clay is going to create, gaps, in the soil from your foundation, which can lead to water infiltration issues, exposure of systems that are not supposed to be exposed to the elements. Cracking of your foundation, whether it's a foundation wall, basement wall, but the mitigation strategy is using slabs, moisture barriers, or sorry, post-tension slabs and moisture barriers and other options. If you have variable moisture, you can expect essentially soil volume fluctuations, and so it's kind of going to absorb that moisture and create more volume, which puts lateral and vertical pressure on the foundation, and you have to control that by either stiffening the foundation or orienting or anchoring the foundation into more friction in the soil with deep piers. Controlled drainage as well helps. I mean, if you're one of the things about a foundation design is that if you can move the water away, move the water away, and it resolves pretty much everything. But a lot of times you kind of don't have the opportunity to do that, and it can be expensive. So you have to consider: is it more expensive to build a cistern, or is it more expensive to build deep piles? And so that could be a key question. Um, in terms of seismic, if you have low to moderate seismic risk, you're not as concerned about liquefaction, whereas if you have high seismic risk levels, you do have some stability and liquefaction risks. And so it just shifts from conventional foundations to mat foundations and seismic basis isolation. The two high seismic ones are about sand and soft clays. And the best way I can describe this one to you is that sandy soils will dampen the seismic forces as it goes through it. So like I live in Southern California, and the best way I can describe where I live in South Orange County is that most of North Orange County is all sandy soil. So while the fault line where most of the earthquakes happen is above that from where I live. It never reaches me down here because it just gets absorbed by that sand. But what that means is the sand will move and settle and act real crazy with a seismic event. And so you need to stabilize that by getting down into deeper soils. And so that's why ground densification or deep piles is going to be helpful in sandy soils. Whereas like soft clays just do a matte foundation because it'll just float above the forces. Um, and then grading and retaining steep terrain. They're going to have soil movement and erosion. You use terracing, retaining walls, reinforced slopes. These are all things that, from site design, if you have any site design experience, you'll have some inherent understanding of. And then if you have loose fill slopes, you're going to be worried about instability and erosion. So you can do soil reinforcement, you can compact it, or you can use vegetated slopes to help sustain that. If it's something that's on like the high side of your building, that's an option. But if you're thinking about your foundation and where you want to put the building, your building pad, that could be a consideration and a possible solution as well. So I want to talk real quick about early design impacts. And again, I'm trying to give you guys some time to respond and ask questions. So I'm going to get through this real quick. Some of the things you might see in the ARE is not going to be just which foundation should I choose based on where this building is. In a valley like this, I can't tell where exactly the elevations are, but I imagine this is a valley, and there's probably some water running through this. And the road might be the low spot, and then like this might be like a drainage ravine. So I'm imagining this dark green is high and this dark black is high, and that's probably very rocky, and this is probably rocky as well. I see some rocks down there. So my guess is what I want to illustrate is if this is your property down here in the bottom left quadrant, you may have to analyze based off of what the soil boring is telling you about the water table, where the water table in the ravine, the light green, is high versus the higher elevation and rocky soil that you have in the dark green. So the area may be asking you questions about when or where to move program across your site. So that would be very much appropriate for the programming and analysis exam because we're not yet in design, theoretically. You may tiptoe into actual design, but a lot of the questions are going to be based off of these big decisions of can we do or can we place a building here? Or if we want to have an L-shaped building that follows the east and north perimeter of a site, does it work with these soil boring samples? And so the answer might be no, we have to move the building to a different location. I think we already talked about that. Oh, I hit the wrong button. There we go. So we can talk about cost implications. I'm going to try to get through this real quick. This is just put this in the background of your mind for everything that essentially your shallow foundations and slabs are going to be your lowest cost. So that requires the least amount of site preparation, excavation, whatsoever. If you have to over excavate for a complicated foundation system, which often happens with like grade beams and things like that, then that's going to cost a lot more money. And of course, deep piles as well. So deep foundations, anything deep is going to cost a lot of money. Excavation is incredibly expensive. And then lastly, the secondary cost implication that is not tied to just essentially how much you're going to have to excavate is your groundwater mitigation. What system are you choosing to manage water? So I do have some sample questions we can go through, but I want to kind of pause and just give you guys an opportunity. I'm going to pop that off for a moment, just to give you guys an opportunity to ask general questions. Lily and Evelyn, thank you for joining us. Normally, what I do at the end of a study hall is kind of I have like a sample of a handful of questions that give you an idea of just in what way would the ARE ask questions about this topic? What different angles would they take? So that's what what you just saw and we're going to go into in a moment. But I wanted to give you an opportunity to just ask some questions, have a conversation, seek clarification.
Well, thank you, Kevin, for the opportunity. But right now, I'm not studying for that kind of exam. I'm studying for the PCM. But
Okay,
I always I always would like to study on this kind of meeting so I can integrate that knowledge on my on my mind
great.
too, you know?
Yes, I mean,
It,
yeah, so especially the questions we're about to jump into, no matter what topic you're thinking about, it is good to experience like, all right, here's geotechnical reports, but to understand five different types of questions and approaches that the ARE might take so that you can take that and then now think about um, I guess firm structures, legal structures, and then it's like, all right, so if it's going to ask about S corporations, what are five different angles it could take to look at S corporations? So yeah, thanks for coming, and I think that's very very helpful. And I'll hang on for a few minutes afterwards if you have some questions about PCM2 that you just want to run through. All right. Well, let's try to stay kind of on topic for a moment. I'm going to finish this up real quick by presenting these questions for your contextual understanding of how the area approaches this. And then we can get into just free-form questions, and it doesn't necessarily have to stay in the realm of geotech. All right, back to the questions. So, move that. Essentially, it the ARE is going to approach this from kind of a few different angles. So you can think about it in terms of like, well, we already talked about system selection, so that's obviously the kind of thing it's going to ask you for. So it might have a question like, it'll give you an excerpt from a geotechnical report, or just show you a snapshot of it. And then you have to read through and answer a question similar to, based on this geotechnical report excerpt, which foundation system should the architect prioritize during schematic design? Right. Pretty simple question. The ARE might present it slightly more complex, but essentially this is an angle it could take. And so in this case, when you read through it, what you're doing is you're scanning for the relevant information to find the answer. And so that in this case, it's the soils, and it literally tells you the soils encountered at the project site are conducive to shallow foundations, including spread footings, continuous footings, and mat foundations. So all of these answer options are deep foundation options, even though it has a deep mat foundation with piles. It's the with piles that disqualifies that one. Even then, if it just was a mat foundations are more expensive than spread footings, and so your correct answer would still be spread footings. Um, it may approach it from like a cost optimization perspective. And I think that's one of the pieces that many ARE candidates, licensure candidates will often overlook when it comes to like technical applications, is that they all have a cost associated with them. Geotechnical report indicates dense, well-draining, granular soils with high bearing capacity, no groundwater concerns. Which foundation system is most appropriate? So in this case, it kind of tells you the description of the fact that it's dense, so we can stay shallow, well draining, so we don't need to worry about liquefaction or expansion, high bearing capacity, uh, yeah, high bearing capacity, so we don't have to go super deep or enhance the foundation in any way, and we don't have any groundwater concerns, so we can just go with a spread footing, which is pretty common. Another one is like identifying risk. So it may take a geotechnical report excerpt like this, show you a table, and say, what is the most appropriate design implication of this groundwater data? I'll give you a moment to take a look at it, and I'll kind of walk through it with you. So on the left column, you have your different boring samples, um, the depth that they went to, the screened interval, which is, I think, that's a technical term I'm not as familiar with, but my understanding is they screen it off at certain depths to understand, I think, the different composition at different levels with more clarity. Don't quote me on that. The depth to groundwater at the time of the drilling. So if there's no groundwater as they drilled it, cool. And then after 24 hours, was there any groundwater in any of these boring samples? And only three of them came up. So and they're all 44, 42, 45.9, so essentially 46 feet deep. So really, groundwater is unlikely to impact shallow foundations because it's so deep. um, Movement and soil behavior. So this is kind of the second part of the analysis, right? Like we can make all of the decisions that we want on what soil is there and what is its bearing capacity, whatever. But then the more dynamic piece is as soil moves and how does it move? So if a geotechnical report identifies expansive clay soils with high shrink and swell potential, what is the most appropriate foundation strategy? Um, so thinking about how it moves, those tables are going to be incredibly important for your preparation for the ARE, because you think about spread footings, expansive clays are just going to start bending them and giving them torsion in a way that's going to be a problem. Slab on grade is essentially going to settle, really unfortunately, and or crack, and create an unstable foundation across the horizontal plane. Um, Deep foundations or a stiffened slab system will get through essentially the expansive clays and provide enough either friction or depth to get to more stable soils below. And a shallow mat without modification is just going to be too weak to get through the expansion of expansive clay soils and high shrink swell. So the correct answer is deep foundations. And then I think this is the last one. Um, but risk identification, oh, actually, it's not risk identification. This is soil bearing identification. So, based on this excerpt, we have maximum allowable bearing pressure in a series of, whoops, my bad. Um, I also messed up the text at the bottom. But there's a maximum allowable bearing pressure. It says perimeter square footings, perimeter continuous footings, interior square footings, interior continuous footings, and transient loads. So like they're essentially just telling you that if you choose or if you're working on these systems, this is the bearing capacity. And so it may ask you to read through resources to say, if the architect is preliminarily sizing perimeter square footings, what's the correct bearing pressure to use? So you read through, you find perimeter square footings. That's the first one in the line here, and you get the answer of 2,500. So I do want to reiterate as I close this up with you guys, um, that these are simplified examples. In that exercise, I'm not trying to show you specifically the complexity and accuracy of what an ARE question is. I'm trying to illustrate to you the different perspectives it might take on a topic. Okay, so they're kind of simplified versions of ARE questions. Okay, so hopefully that was helpful. If you have any other questions about it, let's hear them. And sorry about the noise outside, guys. It doesn't matter when I do a meeting. The landscapers and trash trucks and moving trucks all show up at that time. Is this content mostly shown in PA? I'm trying to understand the question with more clarity. Do you mean like everything I've presented today? Uh, yeah. So think of it this way, right? There's the programming and analysis exam is it essentially stops at kind of when you start real design, which sometimes can happen before or after the contract signing, which starts schematic design. So the best way I can contextualize this is that the geotechnical report will almost exclusively show up in PA. It there may be some implication for background referencing in PPD, but that would be pretty rare. And I'll show you where that is. So the geotechnical report analysis usually is included in your initial information package. The initial information package happens before we sign the contract. It's supposed to be something that they give us, and then we sign the contract. So the analysis of the report and major decision making, it's not quite fully designing the building yet. And that's kind of where the line is between PA and PPD, right? So in PA, um, it'll ask a question like, here's all of your boring samples. These ones show weak bearing capacity. These ones show high bearing capacity. Where should you put the building? Um, so that's really important. To move out of the geotechnical report, it may also say like we have high soil capacity here, um, and it's a linear building. Which way should we orient it for the wind or something like that? So it tries to test just one skill set, but sometimes there are secondary factors that you have to consider. So where it moves into PPD is that now it's going to ask you something like uh, it'll more specifically ask you about like foundation selection exactly. So it'll say something to the effect of if we're using a um, uh, how do I say it? Like it'll say something like if we have a slab, like a post-tension slab that's cantilevering over a slope. Um, what type of footing foundation should we use at the bottom of the columns that are supporting the cantilever, something like that. And then they might have the geotechnical report be a backup for that kind of question. And so it's like, all right, there's like building, location, orientation, like it's kind of like everything in PA is more about like understanding what major impacts there are to cost and feasibility, where the PPD exam starts like, this is what we need to build a building, like to make it happen. Does that make some sense? Where can we find ARE like questions to see what we will be facing? Great question. I know you've been here for a few of my other sessions, and Lily and Evelyn, this is a brand new question to you from me. But I have a few different suggestions in if this, then they change actually based off of which exam and what content. Almost all the time, if you're looking for the most difficult practice exam questions to enhance your functionality as an architect, and then that way is your way to prepare for the ARE, walking the ARE is the best. It's the most challenging, most highly technical. If you're looking for ones that look the most like the ARE, that would be Elif Byram. It's just practice. I think it's just called ARE questions, arequestions.com. If you're looking for kind of an understanding of the basis of like what you're going to get tested on in these exams, and its association to practice. That would be, I mean, I think we ARE and I think PrepARE, my practice exams were pretty good for that. Um, and I haven't really explored some of the other ones, honestly. But those are some of my favorites. If you throw me some, I also might not be thinking of some that I know, but I haven't really looked at in a while. Diego's link, Larry questions. Yep, that's it. Yeah, her questions are fantastic. And she's a great resource. Anything else y'all would like to chat about, discuss? Diego's typing one up. Yeah. So Diego asked, can we circle back on some general knowledge on PCM and PJM, practice management and project management? Yeah, sure. I I'm happy to kind of be a resource for you and kind of talk through some of your questions. I do so on Wednesdays. I used to do just an open office hours for like 4 hours, and I would just kind of be here working on my own stuff, and people could pop in and ask me anything. So I'm happy to offer a little extra time here today to give you like another half an hour of my time to answer your questions. Yeah, well, so I'm not doing it anymore right now because we switched to doing this study hall. But if I if I reintroduce it, I mean you'll get an email about it. But also, um, I'm still available to you. You know, you could always email me and see if I'm available to meet with you. It's not like an official program we have, but I especially, you know, we're kind of PrepARE, and my content is new to the market in a way. So I like to invest in your, you know, experience. The only thing I would ask is, you know, just give us some feedback. You know, we can do an hour meeting sometime. You guys can ask me any questions you want. Just give me some valuable feedback about how to make the program better. Happy to offer that. Yes, my email. There we go. My email's in the chat, and Lily asked, "Is there any schedule for this meeting topic?" Yes, I will add it. I rarely spend a lot of time um, on the front end. Um, I wonder where I can find the. I'm usually kind of back in the I'm in the back end creating materials and stuff, and my partner Mike usually organizes this stuff. Tell you what, send me an email for that link, Lily. I will get it to you. But I just when I click into my resources for it, it brings me to the AI East Bay chapter calendar, which has it on there, but there doesn't seem I can't seem to find right now our singular homepage that is built just for the study hall. So I'll find that and send it to you. Just send me an email, please. Yeah, yeah, you can make an email thread. I don't know, Evelyn. I know Diego said that Lily is a friend of his. But all right, yeah, here you go. Yeah, just send me your emails. I'll do it if you'd like. All right. But also happy to answer any other questions too. I know we recorded the practice management study hall I did 2 weeks ago. I think we forgot to record last week. But that definitely means I've got content in the bag that I can do later on, so it will eventually show up in a recorded format. All right, cool. Thanks, y'all. I'll send you an email on the homepage for study halls. Uh, I will have to ask that as well. I think right now it's going to be, I don't, it would be on the AI East Bay YouTube page or something if they have it, but I will ask my partner about that as well. So to give you guys some background on that, like my partnership with AI East Bay is that I produce the content, I create the materials, and I hand it over to AI East Bay, and they host it, they post it, they promote it, essentially doing all the sales and business side of it. So those kinds of questions I often have to go back to Mike for. So yes. Mhm. Yeah. So if you have questions about that kind of thing too, you could always reach out to him. He'll be the most direct path, but I'll get us all in an email chain with these two questions. Um, and we'll go forward with that. All right. Thanks, Diego. All right. Talk to you later, man. I'm happy to hang around for a few more if either of you have any other questions. All right. Well, hearing none, thank you. Thank you, Lily. I appreciate you guys coming. Come on back every week. We also do, I think, we do a office hours on Sunday. And I used to do the Wednesday 4 hour long one where people could pop in all morning. But right now I'm not sure if we're going to reinstitute that anytime soon, but hopefully I'll see more of you. All right, thanks y'all. I'll talk to you soon.